present here. Today we are going to discuss about the microprocessor and the microcontroller. All of you know about the microprocessor, isn't it? But all of you know about the desktop computer. In desktop computer we have a keyboard, next monitor and the CPU. That CPU is called a microprocessor. Okay, let me discuss about this topic now. In a CPU we have your three units, that is ALU, control unit and the register unit. This ALU is nothing but your arithmetical and logical unit which performs arithmetical and logical operation. Next we have your control unit which controls the all activities of the computer. Okay. Next we have a register. It's a register is nothing but your temporary storage area. Next we have your output device. This output device which receives instruction from the CPU and it displays the instruction in the monitor. Okay. Monitor is also called as a output device. Okay, here the memory unit is used to store all the data which is externally connected to the CPU or microprocessor in a microprocessor system. In case of microcontroller in the sense here this memory unit input output ports are internally connected with the microprocessor system or internally connected with the chip. Now we discussed about the difference between the microprocessor and the microcontroller. The microprocessor in the sense which is the heart of your computer system, and in the sense of microcontroller which is the heart of the embedded system. Now this microprocessor, it has memory and the input output components are connected with externally, and in the sense of microcontroller this input output components and the memory unit are connected internally within a chip. Okay, we cannot use this microprocessor in a compact system, but in the case of microcontroller, we can use this microcontroller in a compact system. Microprocessor, most of the microprocessor do not have your power saving mode. In case of microcontroller, which have your power saving mode. Okay, next. The microprocessor have a less number of registers, hence more operations are memory based. In case of microcontroller have a more number of registers, hence the programs are easier to write. The register in the sense which is a temporary storage area. Next, this 8086 microprocessor is called as a 16-bit processor because it has a 16-bit data bus and 20-bit address bus. Here, it has a 4 general purpose 16-bit register that is called AX, BX, CX and DX. AX is nothing but your accumulator register. BX is nothing but your base register. CX is nothing but your counter register. DX in the sense that is a data register. Now we are going to discuss about the architecture of 8086 microprocessor. In this 8086 microprocessor, it consists of your two units. First we have your bus interface unit and then we have your execution unit. This bus interface unit which is used to collect or fetch the instruction from the memory and it send it to the execution unit. This execution unit is used to execute the result. Okay. Let me discuss about the bus interfacing unit. Bus interfacing unit, it consists of your memory, segment register and the instruction queue and the instruction pointer. This instruction pointer which denotes what instruction is executed next, which denotes the address of the next instruction to be executed. Next, instruction queue. The instruction queue which fetch the instruction from the memory and it's saved in your instruction queue. 6 bytes of data is stored in your single instruction queue. Next, we have your segment register. This segment register which is used to store your result of an ALU, that is arithmetical and logical unit. Now we discussed about the execution unit. This execution unit which collects the instruction from the bus interface unit and which performs some mathematical operations like addition, subtraction and multiplication by using your arithmetical and logical unit. Here we have a general purpose register. General purpose register in the sense that is already you discussed about the AX, BX, CX and DX. These four registers also a 16-bit register which separated as a two 8-bit register, that is accumulator high and the accumulator low. Next, base high and the base low. Next, counter high and counter low, and data high and the data low. Here A1 is represented, H is represented as high. Next, L is represented as low. Okay, next index register. Next we have a flag register. Flag register in the sense